In this example, we're going to look at a hypothesis test. Here we have a work site that's estimated their maximum weight lifted is going to be 25 kilograms or less, and we've got some measures of individual workers that make us think that maybe that's not so accurate. In fact, our sample information is as follows. If you take these 5 observations, so we have n equals 5, we have an x bar. If you take their average, you would get 27.54 kilograms, and a sample standard deviation equal to 5.47065 kilograms. And because we have only 5 observations, we can't really say much about the distribution, but because n is less than 5, we better note that we must assume a normal distribution. And we'll just leave it at that. With such a small sample size, there's not much more we can do than state that assumption. But now it's time to test the hypothesis. So we need to note that our null hypothesis is that the mean is less than or equal to 25 kilograms. Now that's what the work site or the manufacturer is basically saying when they say that that's the maximum value. And that would give us an alternative hypothesis of the mean is actually greater than 25 kilograms. And our data makes us suspicious here that it may be. Now we need to state our level of significance, and a good value to use that balances type 1 and type 2 errors is to use an alpha of 5%. So when you aren't given a specific value to use, then go ahead and use an alpha of 5%. That assumes that you have about equal penalty for a type 1 and a type 2 error. So next we'll need to calculate our t statistic and then compare that to the critical value of t. Our t statistic can be obtained from the equation square root of n times x bar minus the hypothesized mean divided by s, and RT comes out to be square root of 5 times x bar minus 27.54 minus 25 is just 2.54, and divided by 5.47065, I got a t of 1.04 or 1.038. Now we need the t critical. The t critical is we have to note our level of significance, which is 5%. Now I'm not using alpha over 2, and that's because I have a one-sided alternative. So I'm not dividing alpha by 2. So I want alpha equals 0.05, and the number of degrees of freedom is 4. So 4 degrees of freedom and an alpha of 5%. When I switch to that table, we're looking at the 4 degrees of freedom case, so this column here, and we're told that alpha is 5%, so we move down till we find t critical is 2.13. So that's the critical value that we're going to use in this application, 2.13. Going back to our problem and shifting so that we can read this, and we note that t crit equals 2.13 as RT is less than t crit. We have no reason to reject the null hypothesis. So does the data support their hypothesis? Well, it doesn't exactly support it, but I can't prove they're wrong, is what this comes out to be. So we have no reason to reject the work site's MAWL value of 25 kilograms. But I'm very suspicious. If I was working for the union trying to demonstrate that that 25 kilograms is not valid, then I might say let's get a larger sample so that we can assess this more carefully. But for now, we're done with case G.